Okay, let's get started with this Estes Multi-Roc, which is the perfect name for this rocket because it's multiple rockets in one. Basically, and you can see on the front package that there's 6 different configurations for this rocket, so you can kind of fly it as 6 different rockets. It's a very modular rocket per se. So due to the nature of the rocket with the 6 different configurations, it's very complex, and there's a lot of time required to build this rocket. It definitely takes a lot more time and energy than a lot of other Estes rockets because it is 6 rockets in one. And I will say it is less effort than building 6 rockets. It's somewhere in between the time for building 1 rocket and 6 rockets. And there's kind of a lot of advantages to having 1 rocket in 6 different configurations because you only have to carry 1 rocket around with you and fly it in 6 different ways, which is pretty cool and one of the highlights of this kit. And since there are so many different steps required in building this rocket, that means there's basically a lot of different ways to build it. So if you have any other ideas or alternate methods or build techniques, please leave those in the comments so we can try to learn from each other on basically finding the optimal way to build this rocket. Also, if there are any questions, it's better to ask the question than to have a unsuccessful flight. So comments are welcome, regarding questions and different types of build techniques. So the first thing I'm going to do here is glue the centering rings onto the motor tubes. There's 2 motor tubes for this rocket, 1 motor tube for the booster and 1 motor tube for the sustainer, and they both have 2 centering rings each. Now, I'm gluing the centering rings on the tube in accordance with the placement that is in the directions. So you see me first marking the tube with a ruler there and then gluing the rings on. Now, if your motor tubes are kind of smooth or glossy in appearance, make sure you scuff them up a little bit. I like to use 220 grit sandpaper for that. So the reason I'm working on these motor tubes first is because the glue has to dry, almost fully dry, before you can move on to the next step of the rocket. So I like to put these centering rings on and let them be drying while I'm working on the other parts of the rocket. I also want to note to make sure that you place the centering rings on the right part of the tube in accordance with the directions, because if you don't, since this is a 2-stage rocket, you could get basically, I guess, what I'd call like an adverse tolerance stack up, where the coupler and the motors wouldn't fit together perfectly inside the rocket, which they need to since it's a 2-stage rocket. So it appears that you can just put the centering rings anywhere on the tube for this rocket, and you can for some 1-stage rockets, but not on this rocket. So make sure you're accurate with your markings on the tube when you glue these centering rings on. Also, when you're gluing the motor block in the sustainer motor mount tube, make sure that you don't use too much glue, because if you get excess glue inside the motor mount tube, the motor might not fit all the way inside the tube, so be careful with that. Now I'm cutting out the fin alignment guide, which is used to wrap around the tube to make sure that your fins are spaced evenly around the rocket. Also included on the fin alignment guide is a marker for the launch lug and a marker for the glider. Next, I'm going to scuff up the tubes a little bit with the 220 grit sandpaper. This allows the glue to stick a little bit better to the tube. And for this sustainer section, I only scuffed up the bottom of the tube because I'm only gluing stuff to the bottom area of the tube, which is what you see me mark there with the pencil. So when you wrap the fin alignment guide around the rocket, make sure that you tape it together with painter's tape, because you need to use the same fin alignment guide for both the booster section fins and the sustainer section fins. So you don't want to tear the paper by using regular tape. The painter's tape will allow you to preserve the fin alignment guide for using on both stages of the rocket. So there's two markers on each end of the fin alignment guide that are used for making sure that the fin alignment guide is on straight on the tube. So be very careful to make sure that those markers are lined up, because if they're not, then that means that your fin alignment guide is not straight on the tube and your fins will be offset from where they're supposed to be and not equally spaced around the tube. So here I'm making a marker for each fin, or two markers for each fin, one forward and one aft, which I will use to connect together when I draw the lines that are going to be used for placing the fin on the rocket. So next I'm going to repeat this process for the sustainer section of the rocket, and basically everything is the same except that you're going to draw two more markers on the sustainer that you didn't for the booster, which are going to be for the launch lug and the glider placement. And make sure you mark the markers for the launch lug and the glider so that you know that those markers are not for gluing fins, but they're for gluing the launch lug and the glider. So by this point in the build, we're starting to get an appreciation for the complexity of the rocket and the high number of steps required to build it. So I wanted to say that if you're not a very experienced rocket builder and you're still attempting this kit, to buy two of them, because if you mess up or mess up in a way that is irreversible, then you can just take the parts from the other rocket kit that you need to basically just use two rocket kits to finish one, and there's no shame in doing that, and you'll have some parts left over maybe from the other kit for building other rockets. So here I'm drawing the lines for the fins. I'm basically connecting the markers together, two markers for each fin, like I was saying earlier. Now the length of your lines only need to be a little bit longer than the length of your fins. I do want to say the lines for the launch lug and glider do need to be a little bit longer because you're placing those parts higher up on the tube. And note here that I'm using this piece of angle iron or angular metal piece to draw these lines on the rocket, and I highly recommend using a tool like this. It just makes drawing the line straight much easier. You can also do this with a door frame in your house. You just place the tube vertically on the door frame and just kind of run your pencil along the side to draw your line. And that method works, but it's a lot more difficult than using the angle iron. So I highly recommend getting a piece of angle iron, even if you're only going to build one rocket. It's not so expensive that it's not worth it, and it really helps you to draw the lines much straighter. And now we're going to cut out the fins. There's a lot of fins for this rocket, 8 fins, 4 on the booster and 4 on the sustainer. And in my kit, they were relatively easy to punch out of the fin stock, which was good. It makes it easier, less time required to get the fins out. Now, if the fins supplied in your kit are not easy to punch out, I recommend taking your time and not forcing them out, because if you kind of force them out, you can break fragments of the wood, which could require you to have to do a lot of sanding or even break your fins such that you can't use them. So be careful with that. I also want to say that I really like the design of these fins. They're kind of a classic design. You see this design in other kits such as the Estes Goblin, and the Estes Goblin is becoming one of my favorite Estes rocket kits because it flies just very straight. So I have the expectation that the Multi-Roc will also fly very straight. So here I'm putting a layer of glue over the line that I used to mark where the fin's going to go, and I'm just going to put a layer on for each fin and let it dry. What that does is when I do actually go to glue the fin on is make the joint a lot stronger, because the glue that's going to be used for attaching the fins not just going to seep all into the tube, and you'll see me do the same thing for the fins later on. So I want to talk a little bit more about why this is such a good fin design and why I think it's going to make the rocket fly so straight. And that's because the fins are very large and they have a very large surface area, and they're placed on the bottom of the rocket and they're swept a little bit aft. So what that does is it puts the center of pressure very close to the bottom of the rocket. If the fins weren't so big, the center of pressure would be located closer to the nose cone of the rocket, and that would reduce the stability a little bit. So when you have these really big fins with a lot of surface area towards the bottom of the rocket, it can really help the rocket fly straighter. Now I'm going to sand the edges of the fins. The most important part here is to make sure that the root edge of the fin is sanded very straight so that it's completely parallel with the body tube. You want to place it on the body tube and make sure that you can't see any light come through, so that way the fin is making full contact with the body tube. And next I'm going to glue the motor mount tubes into the rocket, which is probably the most difficult part of building this rocket, because if you do mess up, basically the damage is irreversible. So what I do here is I'm taping two motors together. These are used motors, and these are the way they're going to be taped together when I actually fly the rocket. So that's why I'm doing this here, to make sure that everything is spaced perfectly. And here I'm kind of test fitting the parts to seeing how it's going to go together. And here I want to note that the red tube coupler that you're going to see here in a second is glued into the booster section and not into the sustainer section. You don't want to glue the booster to the sustainer with the coupler. You only want to glue it into the booster. So here I'm starting out with putting some glue in the booster section, and I'm going to glue the motor tube in, and then I will put some glue in the booster section that's going to be used for bonding the tube coupler to the booster section. There I did a test fit to kind of see how far it looks like it's going to go into the tube. Okay, so here I'm gluing in the tube coupler to the booster section, inserting those motors, getting everything lined up, and now I'm going to put some glue in the sustainer section. I want to emphasize to make sure that you put the glue kind of far up into the tube, so that way when we're kind of lining everything up, that glue does not get on that tube coupler, because like I said before, it's only being glued to the booster section, not the sustainer. Then I kind of push everything together to make sure that everything's basically, stacked up properly. I wanted to get the motor mount tube for the sustainer inserted the right distance into the body tube. And then I go ahead and pull the booster section out, and I decide to leave the motors in that sustainer section because I was worried that if I tried to pull them out, I might move the motor tube too much and mess up my alignment. Okay, so now I'm going to put a layer of glue on the root edge of all the fins and let it dry. This is just such a good technique for bonding balsa wood fins to these cardboard tubes. When you do this joint like this, where you have these layers of glue that you let dry first on the fin and the tube, the bond is so strong. More often than not, the bond is actually not going to break, but either the fin itself will break, the wood will break, or the tube itself will start to peel away. So I can't really imagine using another technique than this. You might get a stronger joint if you use a different type of glue, but the wood glue works great. It's non-toxic and it's easy to use. It dries relatively fast, and this is just a great technique. So the only thing really slowing us down here is that we have 8 fins, but hey, we're going to have 6 rockets in one when we're done with this. So It's a little bit more work up front, but well worth it in the end to glue all 8 of those fins on there. 4 fins are better than 3 as far as the rocket flying straight, and you need 8 fins to get the 2 stages when you got 4 on each stage, so the work is well worth it. Alright, here I'm in the process of gluing the fins to the booster section, and the way I like to do it is to put a layer of glue on each line for each fin and go all the way around and let it partially cure such that it's sticky, so that when you put the fin on the tube it adheres to it well, and you don't have to hold it in place or anything. It should just stick, stay in place. Now, if I built this rocket again, I probably would not do this part with the booster section not attached to the sustainer section, because I did not have much tube to hold when I was putting these fins on. So there's basically like not enough room to put my fingers on the tube to mount the fins, which added a little bit of difficulty. And the reason I did this, I think if I remember correctly, is because the motor mount tube in the sustainer was not fully dry yet, and I didn't want to connect everything back together and risk messing up my alignment that I worked so hard to get, which you saw earlier. But I did succeed here. It was a little bit tricky. There's a fin that just fell off, so I had to redo that one. But I did get it done and turned out okay. So when I first put the fins on there, they weren't perfectly aligned and perfectly straight or parallel with the tube. So I made a few adjustments once they were already attached and the glue is still not fully dry yet. I just kind of looked at it from above, the aerial view there, which you see in basically this camera angle, and just kind of did the best I could with it. And I think that they're straight enough or aligned good enough. And then what you see here is I'm putting a couple, I guess you would call it tacks on there to make sure that they just kind of stay in place and don't move while I let it dry. So it looks like I assumed that the sustainer section glue on the motor mount tube was dry, so I went ahead and pulled those motors out and started to glue the fins onto the sustainer section, which is pretty easy after doing the booster sections that were so big and not having a lot of area to put your hands to work on it and put the fins on. So this will be simple after the booster section, and the process is the same. I go around, and put a layer of glue on each line where each fin's going to be and let it dry till it's sticky. So nothing new here that's different from the booster. And these fins just go on great. I did have to make a few minor adjustments to them after I glued them on there, and I did put the tacks on there like I did the booster section fins while I let it dry. But yeah, putting on these sustainer fins was a real success. I was so good at putting fins on after doing that booster section that these sustainer section fins just went on very well. So now I'm going to start talking about the next stage in the build of this rocket, which is the glider that you attach to the sustainer that pops off when the ejection charge goes off and glides down to the ground like an airplane, and is super cool. And this is a really neat feature of this rocket. This is actually the first time that I think I've assembled a balsa glider that attaches to a rocket like this. There was an Estes rocket called the Manta back in the 1990s that had a foam glider that attached to the rocket and glided down. It's basically the same principle, but that one you didn't have to assemble, and this one you do. And there's a whole lot of intricate parts here, a lot going on in assembling this glider. So we're gonna watch me try to do it here and see how it goes. I'm not completely sure that I put it together in the right order, the best way, using the best technique. So again, if there's a better way to do it, please write about it in the comments. So punching the parts out of the fin stock went relatively easy. for the kit that I had, and it just takes a long time because there's so many parts. And as you think about how you're going to glue all these parts together and have them perfectly aligned, it might be a good time to think about having that spare rocket, because like I mentioned earlier in the video, this rocket has a lot of kind of complicated parts of the build that are easy to mess up, and putting together this glider is one of them, unless you're like really experienced in doing this. Okay, so it looks like I'm almost done punching out all the piece parts. Here I'm going to test fit the two tail pieces together. I guess you'd call those the vertical and horizontal stabilizers. And it looked like the test fit went pretty well there. Now I kind of just look at these parts to try to see how they are going to go together, and then I started doing some sanding here. I got the 220 grit back out. I'm treating these wings basically like I would fins, and I'm going to go ahead and put a layer of glue on those root edges of those wings here in a second, because that's the best way I thought to glue these pieces together, with the double layer of wood glue, just like I do the fins. And then while I set that aside to dry, I go ahead and do some sanding on the rest of the piece parts. I had a little bit of pride in my work here. I didn't want to just leave the edges completely rough, although I knew I wasn't planning to seal or coat the glue or coat the wood with anything besides the spray paint, but I did at least want to get the edges somewhat clean and not have any burrs on them. So while I was doing this sanding, I started thinking about how I was actually going to glue this together and basically put the parts in a way such they were going to dry in the proper alignment or orientation, and just so that the glider was built properly. I did one time think about using an adhesive that glued more quickly than the wood glue, such as a 5-minute epoxy, but I chose to stick with the wood glue and try to use some of the tooling or support equipment that was supplied with the kit. By that I mean these little pieces of wood that are used to prop up the wings such that they're at the right angle of dihedral, which is kind of funny. It took me a few tries to get the wings to stay in the right spot when using this tooling, but I eventually got it. So this way does work, but there's most certainly a better way to do this than I did here. So leave those in the comments, because here we are watching me fumble around with this stuff before I get it. So it's definitely probably wasn't the best way to do this. Looks like I'm doing a few more iterations here before I get it to stay. Be careful not to breathe on it or look at it the wrong way even, or accidentally bump your desk or anything, because otherwise it's going to collapse and fall down like it did. I don't know, I didn't count how many times it was unsuccessful in this video, but if you want to poke fun at it, go ahead and count how many times I had to readjust these wings here to get them to dry at the right angle. And so after I finally did get them where I wanted to, I just didn't even move it out of the way. I just let it sit there and dry. And while I did that, I went ahead and put some fillets on the booster fins. And these are obviously for strength. So if you watch my technique here, you'll see that I basically put a bead of glue at the intersection of the fin and the body tube, and then I run my finger along it, and that's to make sure that I basically clean off some of the excess glue, because if I don't, it's just going to drip off of the booster section onto the paper, and if it does that, sometimes it kind of forms a bead towards the bottom or the top, depending on if you have it upright or not, and it looks really bad, and it's really hard to remove it after it's dry. So I like to just put on as much as I have to. Okay, look at this here. I'm putting some extra glue on the top of this wing because I'm scared that it's gonna break again, and I wanted to make sure that those wings stayed in place. And back to working on the fillets on the booster. And you can look at this booster section and look at the size of these fins. They almost look like wings in and of themselves. And that's actually good because as the rocket flies, this booster section, after the sustainer motor lights, is going to just flutter down by itself. So it is good that the fins are really big because they'll catch a lot of air and it will fall relatively slow to the ground, slow enough such that hopefully the booster section does not get damaged. And it seems like doing all these fillets is taking forever, but there really are a lot of them, 8 per stage for a total of 16 fillets. And we've been watching me work on this booster section for a while, and I haven't even started on the sustainer section yet at this point in the video. But this really was a good time for me to do this because I'm letting those wings dry. And you saw earlier I ended up putting another tack toward the trailing edge of the wing there to help it give it some more strength while it's drying there because I didn't want it to break and have to redo it. Alright, so now I'm going to start on the fillets for the sustainer or the upper stage. And as I was watching this video, I'm looking at the shape of these fins and I really like them. There's a lot of advantages, especially how they are swept aft behind the bottom of the body tube, which this might sound silly. For one of the reasons I really like them is because when I can store this rocket, when I'm not flying it, it will stand up on the 4 fins. And that means that you don't have to lean it up against another rocket or the wall or whatever, when you don't have to put it on a little post to make it stand upright. It'll just kind of stand upright on its own. Now, fins that are swept aft beyond the bottom of the body tube on larger rockets can cause a problem because basically there's no way that on a larger rocket that's coming down on a parachute, there's no way that the body tube is going to impact the ground first. It's going to impact the fins, which does make them more likely to break. But on a really light rocket such as this one, or an Estes rocket, it does not pose a problem. So it looks like the glue joint between my port and starboard wings was successful, so I went ahead and put a fillet between them for reinforcement, and then put the 2 pieces of the tail together. And gluing the tail pieces together went pretty well. I had to just be careful that the 2 parts were at 90 degrees to each other. Well, they definitely weren't 90 degrees exactly, but they're as close to 90 degrees as my eyes could see. So just did a few adjustments there to make sure I got that 90-degree angle. And then I put it aside to glue together the 3 parts of the fuselage. So gluing the fuselage pieces together wasn't terribly difficult or terribly easy either. Basically, the way I did it was that I just put some glue on the pieces and kind of held them together, and I tried to line them up perfectly relative to each other. Of course, they weren't perfect, and I kept making all of these adjustments with my fingers because I would keep thinking it was perfectly aligned and then it wasn't. And I believe that as I was making all these adjustments, the glue was starting to cure a little bit such that it became a little bit stickier and stickier. And then when I got it to a point where I was satisfied with it, I just held on to it and didn't move. And that's kind of the way I did it. You could probably use some sort of tooling or a vise or something else besides just holding it together with your fingers to get it aligned more accurately, but this is what I did, and it looks okay now that it's done, which you'll see later in the video. And here I want to point out that no, you did not accidentally hit the pause button and your screen is not frozen. It's just that I'm actually holding this in place that steady, and wow, I never knew I could hold my hands this steady. Well, now that I'm saying that, it looks like I'm moving them, but nonetheless, I think I did a good job holding this in place and letting it dry. So eventually I get to a point where I believe that the glue has cured enough such that when I lay the parts down that they do not move relative to each other. And then I move on to the next part of the rocket, which is gluing on the launch lug. Now Estes provides a distance from the bottom of the tube to which the bottom of the launch lug is placed. So I go ahead and measure that approximately, and then I mark it or put the marker for the bottom of the launch lug. And then I hold the launch lug up to the rocket to make a marker for where the top of the launch lug will be. The reason I do this is because I don't want the bead of glue that I use to glue on the launch lug to be longer than the launch lug itself. And that is because I want the section of body tube that is aligned with the launch lug that may make contact with the launch rod to be as smooth as possible. And this is especially important on this rocket because basically there's 3 sections of tube. That is the booster section, the sustainer, and the payload part of the sustainer. And when you couple a lot of these tubes together, they're not completely aligned straight, so there's less range of motion for the launch rod, and there could be more friction than there would be if you basically just had a regular one-stage rocket with a cone on it. Speaking of the nose cone, here it is. I just sanded it off a little bit so that the paint would stick better. And here is the coupler for the coupler that goes between the payload and the bottom part of the sustainer section. And one of the parts you have to do with this is glue this cardboard ring onto it so that it fits into the tube, and I use cement for plastic models for this. Then I'm going to do a little bit of cleanup here before the next step. And the next step is going to be cutting out the shock cord mount, which is somewhere buried in the booklet of instructions. There are a lot of instructions for this rocket because there's a lot of steps. Nothing too crazy there, you just cut it out. And then watch carefully how I'm going to glue it on here. I try to keep the glue towards the center, but also put a little bit of glue towards the sides so that it's evenly distributed on the paper, because if you put too much on there, then it's just going to, the excess is just going to spill out and you're going to have to clean it up. And if you don't put enough on there, then the paper is not going to all stick together. So you got to put the right amount on and then hold it for a while so it can dry. And now that that's dried enough to set it to the side, I go ahead and put some fillets on the tail section of the glider for strength. It's basically nothing different here than the fillets we did for the fins. Alright, and the next step here is gluing the, I guess you'd call it the mounting dowel to the glider. The way this works is that this wooden dowel will slide into a piece of tube on the sustainer section of the rocket that in such a way that the glider kind of hangs on the rocket, or basically the part of the dowel that's not glued on to the glider sits inside the tube. And when you're gluing it on, you have to be extremely careful that the dowel is parallel with the fuselage of the glider, because if it's not, the glider is going to hang sideways. So make sure you look at it from a bunch of different angles and let it dry pretty thoroughly before you set it to the side. Alright, so here we're going to watch me hold it for a little bit while it dries. And the next step is going to be gluing on the tube to the sustainer section of the rocket from which the glider hangs that I was talking about earlier. I'm going to go ahead and pull that out of the package, and Estes gives us a distance from the bottom of the body tube from which to mount that tube from which the glider hangs, and make sure we get that fairly accurate, or else the glider is going to be too high up on the rocket or hanging below the rocket. There's the little tube there. It's pretty short. It's made out of the same material as the launch lug is. And I basically use the same technique for gluing it on as I would a launch lug. Make sure that there's not too much glue such that it kind of overflows forward and aft of the launch lug. Just be careful to put the right amount on, and also look at it from a bunch of different angles to make sure that it's glued on straight, or at least as straight as you can see. There I went ahead and put a little bit of reinforcement on that wooden dowel on the glider just to make sure that it's super strong. And here are the cans of spray paint that I'm using to spray paint the rocket, green and white. Next, I'm going to spend quite a bit of time putting some fillets on the launch lug and the glider mount for the tube. I didn't want these things to come off, so I tried to make sure that they were on really strong. And with this, again, be careful not to use so much glue that it doesn't drip up and down the body tube when it dries. As you can see, I had to remove a little bit from the forward area of the launch lug there. And my next step was to spray paint the nose cone and a portion of the payload section green. And the way I did that was that I just had the nose cone sitting on top of the payload section and just spray painted a little bit, about an inch below the nose cone, onto the payload section of the tube to make sure that I had enough paint to have a thick enough stripe, because you see on the picture there's a green horizontal band going around the bottom of the payload tube. Okay, in a second you're going to see what I'm talking about, because that was kind of a hard explanation to follow. But there's the payload section with the green band around it. What I'm going to do is put some painter's tape around the top there and paint the rest of the tube white. And so obviously the area where the painter's tape is at is going to stay green, and the rest of the tube is going to stay white, and that'll give us that green band going around the payload section of the rocket. So I went ahead and spray painted the different sections of the glider white and green in accordance with the color scheme on the picture that was included in the kit. And I did this way because, I don't know, it just seemed easier than spray painting it after it was all glued together. Now obviously after spray painting it, the joint between my wing and fuselage and tail are not going to be as strong as they would have been had I glued it together before spray painting it. But with using this epoxy here, I figured it would still be strong enough. And so you can see my wings are spray painted white at this point. And here we're going to watch how I glue the wings to the fuselage, putting a bead of glue across the joint there. And with the next step, the gluing of the wing to the fuselage. I don't really do anything fancy. I just put the fuselage on top of the wing and I adjusted it until I thought that the fuselage was parallel with the wing and just let it sit to the side to dry. Next I glue the coupler for the payload section inside of the payload section with the Elmer's glue there. Nothing too fancy here. I just insert it up to the point that basically all the cardboard is inside the body tube. If you look in the background there, you can see that the sustainer section of the rocket is now painted white. And so while this stuff dries, I go ahead and take the opportunity to glue in the shock cord into the top of the sustainer section. And when you do this, make sure that you insert the mount far enough down into the tube. Otherwise, there could be interference between the payload section coupler that we just glued in and the shock cord mount, and your rocket will not fit together. And also, when you put this in, the shock cord mount in the tube, make sure that you let it dry long enough such that when you remove your finger that the payload section mount doesn't come off with your finger and you have to reglue it. And after I finally let that dry long enough so that I'm comfortable letting it go, I start to work on the recovery system for the sustainer section of the rocket. And for that, I chose to use a streamer made out of crepe paper instead of the parachute that was supplied with the kit. And if you've watched any of my other videos, by now you know that I basically only use a parachute unless I think I really have to. And that's because I don't like my rockets to drift too far away from the launch pad, because I like to get them back. I'd rather get my rocket back with a cracked thin joint than I would not getting it back at all, or having to try to fish it out of a tree or something. But here's my technique for making the streamer. What I do is I cut a length of crepe paper and then I put tape over it. Here I'm using the painter's tape because I couldn't find my masking tape, but either painter's tape or masking tape works well here. Just make sure you put the tape all the way along the length of the crepe paper, and that makes your streamer strong enough. I like to use this technique because this type of streamer rolls up really well as far as fitting inside of your rocket, and the paper, or the stiffness of the paper, is not affected very much by the temperature of the outside air, so it will not stick together too much in cold weather. Although I will still say make sure that you don't let it sit in the rocket too long before you launch it. Okay, here I go with sanding off the coupler on the booster section. It was basically too tight before I sanded it, and when the second stage motor lights, I wanted the booster section to be able to kind of fall off easily. I didn't want it to be too tight because it would build up too much pressure and put too much stress on the rocket, and that could damage the booster section of the rocket, burning it up too much basically, or kind of causing some damage to the tube. So I put a lot of work into sanding this down till it fit, kind of the way I wanted it to. By that I mean relatively loosely. So here I'm just going to speed up the video a lot, and man, I wish I could sand as fast in real life as you see in that video there. That got the job done quick here, huh? And next we're going to go back to the glider section, and by that I mean we're going to glue the tail section of the glider to the fuselage with epoxy. I'm just going to mix it up like normal and put some glue on the mating parts. And again, I'm not doing anything crazy here. I basically just put the glue on the tail there and stick it inside the fuselage and hold it to let it dry. You got to be a little bit careful here to not use too much, because you don't want the epoxy to basically flow out of the glider and I did have a little bit of excess there. As you see, I had to kind of get a little bit off with the paper and popsicle stick, and the way that it was glued together, it just kind of the pressure between the sections of the fuselage were enough in and of themselves to hold it together to the tail section. And now I'm just going to put some fillets on the important joints of the glider. I just kind of put the extra glue where I felt it was needed. I didn't really use a whole lot of logic here. Obviously, you need to balance out the glider with the clay that was supplied with the kit, because putting all this epoxy in all these different places is going to really mess up the distribution of the weight of the glider, which will have to be corrected with the clay. I want to note to be careful not to put glue on too many different sections of the glider at once here, because you can only really sit it down in one orientation to let it dry. And if you have glue on two different sides of the glider and it's kind of, I guess, flowing or beating up as it flows towards the whichever side is pointing down, you basically won't be able to readjust it the way you need to because there's glue on the other side. So just kind of do those one at a time if you can. Alright, now we're going to get started on the decals for the rocket, and there were a few decals for it, not a whole lot, so I'd say the decals were of medium intensity. Basically, you have decals for the fins and the wing, and you see that decal that's the green stripe there. I failed to see that that decal was included in the kit, so that's why I spray painted that green stripe on the payload section of the rocket earlier, but that works just fine. And also, I want to point out that these decals can kind of tear easily, especially if you didn't put a whole lot of work into making your fins smooth, like I did not. So if you tear one, it's okay, just be patient, and this is also a good time for that other kit that you purchased to come in handy if you did buy that spare kit, to use decals from that if you need to. If they kind of get crumpled up or start tearing, it's normally easier to just start with a new decal. So what you're going to see me doing a lot here in a second is holding up the decal to the fin to kind of do a test fit. The decal is, or the surface area of the decal is almost as big as the fin, so you have to be really precise with your cutting to make sure that you cut enough of the decal or the invisible part of the decal off so that it's not overhanging off the side of the fin. And here we're watching me try to finesse this decal on here. You see it kind of rolled up a little bit there, and kind of playing with it a little bit to make sure I get it right. And if you make sure you use a lot of water here, or put another drop of water on if you need to, that helps the decal to settle out and be flat on the fin, and it's less likely to tear when you have a lot of water on it. So now we're going to kind of blaze through watching me put the decals on the other fins. I didn't use all the decals for all the fins because basically I didn't take the time to do that. But as we'll see in a second here, that ended up being okay, because when I went to put the decal on the glider, I actually messed it up and some of the decal paint came off, and I had to cut out the section from one of the fins to kind of repair the decal on the glider. And okay, here it is right here. So here's the decal on the glider. They only give you one of these, if I remember right, and that's kind of bad because they only gave me one of the decals of, which is the one that I messed up. So I didn't have a spare, so that was kind of bad, and I was really sweating it out that I'd come this far without having to buy that spare rocket, and I thought I was going to have to buy another one just to get that one decal, but I did end up actually repairing it successfully, which we'll see here in the video in a second. So make sure that you test fly your glider before flying it on the rocket. Make sure that you add clay where needed to make sure that the glider is stable and glides well. If you don't add the clay, it will not glide in a straight line and it will not look good when it's coming down from the rocket. The other thing is, if you're flying this rocket with the payload section, make sure you add some tape around the nose cone to ensure a tight fit between the payload and the nose cone, because if the friction is not great enough between the payload and the nose cone might separate upon ejection and free fall down to the ground and might hit something, or you might lose it. If you want to fly this rocket without the payload section, you're going to have to make a shock cord mount for the nose cone. And you can do this the same way we made the shock cord mount that was glued into the sustainer body tube. I don't think that it's supplied with the instructions, so it might be and I didn't see it, but you make it that same way. It's not too difficult. Alright, back to the decals. I'm still working on this decal on the glider. Okay, see there I cut off the piece where the paint had come off the decal that I'm going to replace with a piece of green decal from one of the fin decals. And I think we're going to see me do that here. Yeah, okay. Here I'm applying that other piece. It's kind of hard to see, but basically I took the kind of the pointed end of a decal from a fin and put it on the part of the glider decal that came off and blended it together, and it turned out shockingly well. It looks great. Alright, now we're going to do some work on the recovery system here. I'm going to attach the streamer to the shock cord, and I do that with another piece of elastic. Here I'm tying the payload section to the shock cord. Make sure that if the tail from the knot is long, that you cut it off so that it doesn't get stuck in between the coupler and the body tube. I punch a little hole in the end of the streamer here to put the piece of elastic to that I use to tie the streamer to the shock cord. See me do that here in a second. Yeah, there we go. That's my attachment piece there. I barely made the hole big enough to get that cord through. Yeah, I just tie it together with a couple regular overhand knots here, and it's good to go. And that's basically it for the recovery system. Just going to roll up the streamer here and put it back inside the rocket. And that's all I have for this video. Again, be sure to leave any questions you have in the comments section, or any alternate build techniques such that we can improve on how we're building this rocket. And also be sure and subscribe in case I upload any future videos. Thanks for watching.